Graphs can be functionally the same, but built in a handful of different ways. If you're using an object-oriented language, you could create vertex and edge objects and give them each properties like name, strength, ID number, etc. A vertex could have a list of edges it's connected to, and vice versa. However, operations that traverse graphs can be more inconvenient if you need to search through vertex and edge objects. There are several ways to represent connections on simple graphs that only use lists. One example is an edge list, which is precisely what you'd think. It's simply a list of edges. The edges themselves are represented by a list of two elements. Those elements are normally numbers that correspond to ID numbers for vertices. So, in the end, this list is just showing two nodes that have an edge between them, and an edge list is the list that encompasses all the smaller lists. Because our edge list contains a list of other lists, it's sometimes called a two-dimensional list or 2D list. If you had a list of lists, that would be called a 3D list, and so on. An adjacency list is another way to represent edges in a graph. In an adjacency list, your vertices normally have an ID number that corresponds to the index in an array. In your array, each space is used to store a list of nodes that the node with that ID is adjacent to. For example, the opening at index 0 represents a vertex with an ID of 0. That vertex shares an edge with one node, so a reference to that node is stored in the first spot in the array. Again, our adjacency list is two-dimensional, since it's a list that contains other lists.